All right, everybody, welcome, welcome. As you can see, today we're going to do transformer phasing. So what is that? What does that mean? Well, on the left-hand side, what you can see is a transformer here, or the symbol for a transformer anyways. What you have on one side is the primary side. That's when your line voltage comes in. That's your 120, okay? And you go through the transformer, the primary side, you come out the other side, and you use all the voltage, the load, and what it does is it gets all the electrons on the secondary side moving, and you create 24 volts in this step-down transformer, okay? And then the electricity goes out from there, around to your circuit, and back to ground or C on the secondary side. So the idea with transformer phasing is that we want to make sure that the primary side and the secondary side, the electrons are moving the same way at the same time. In a sense, is what they call it, they're in phase, okay? So the idea becomes we got to make sure that we ground the right sides here. Now, what we want to do, or what we can do, if we want to check this with a multimeter, we can start to check what the difference is in potential from one side to the other using a multimeter. So for instance, if we checked from line 1 to neutral, you would get a difference of 120 to 0 or 120. If you checked line 1 to C, you'd get 120 to 0 or 120. Now the key for this thing is checking from line 1 to R. So if you go to line 1 to R, the difference in potential is 120 to 24 or 96 volts, 99, 96 volts, okay? Now, what this represents over on the sine curve, the bigger curve, that's your 120. Okay, that's your primary. And then the secondary side's this guy down here, that's your 24. What the left-hand side is representing is that we're in phase. We're moving at the same direction. And how we can tell is if we use our multimeter, we would get our, once again, 96 volts, the difference in potential there. It's moving the same way at the same time. So the difference from there to there is 96. This is in phase. That's the idea. Now, another neat little check you can do, maybe we grab another pen, a different color here, we can check which way the actual power is going. So for our line 1, we always go from high potential to low potential. So line 1, 120 down to 0. We're going to come in and we're going to go that way. Here, this is a source on this side, on the secondary side. So we're going to go out from the source. We can go to source, we can go to a switch, we can go to a load, and we can come back. And what you can see is that they're going in the same direction. We kind of proved that this is what we're doing here. That's when we say a transformer is in phase, okay? Now, let's just say we switch things up a little bit, and we're going to make it a different style. So what we'll do is we will take the transformer, and instead of having the C grounded, we'll ground the R. So we'll make that 0 volts, okay? And the C then becomes negative 24 volts. What we're going to get at is if you take a look at the sine wave again, the C ends up going, or the voltage or the phase on the secondary side ends up going in the opposite direction. We're going down in a sense. What we go down to is negative 24, and this is 120, okay? So the key here, once again, is not necessarily L1 to R, but L1 to C. What's the difference? If you go L1 to C, what do you get? Well, 120 down to negative 24, that is 144 volts. And we say that is out of phase, okay? Now, once again, we'll go back to our trusty blue pen and take a look at the way the power is moving through here. Line 1, through the transformer, out the neutral side. That doesn't change. But on the other side, the secondary side, we don't start from the R anymore. All right, that's the ground. That's where we're ending up. We got to start from the other side. So we start from this way, source, switch, load, and we'd end up coming back. And now you can see they're going in opposite directions. This guy here going up there, and this guy on the secondary side going down there. And what you get? You get 144 volts. All right? I hope that worked for you guys. Thanks for watching. Take care. Have a great day, and we'll see you in the next video.